Now I want to talk about graphing radical functions. So let's look at a couple very simple radical functions. We can see what these look like and figure out the best approach to graph them. So the first function I want us to look at is the square root function. This just takes the square root of x. This function pairs each real number with its principal or positive square root. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Its domain is from 0 to positive infinity. And its range goes from 0 to positive infinity as well. It kind of looks like half of a parabola turned to its side. Imagine I'm doing the I'm a little teapot dance. Next, this function pairs each root with its cube root. This is the cube root function, okay? And remember, cube roots you can take the cube root of odd numbers. So the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. Because x can be positive and negative, and y can be positive and negative as well, our domain and our range are all real numbers. So when we're graphing a square root function, you need to graph by finding at least 3 values. So you need to find at least 3 y values. Be really careful in how you choose your x values, okay? You want to set up your radicand, that's what's under the radical right here, to be equal to perfect squares, okay? So I would do this by setting, if you're taking the square root, you're equal to perfect cubes. So I would say x equals 0, x equals 1, and x equals 4. These are the first 3 perfect squares, okay? We will do an example with cubes later on in this slide. So I go ahead and I substitute in these perfect cubes. If I take the square root of 0 minus 2, the square root of 0 is 0, minus 2 is negative 2. If I take the square root of 1 minus 2, I'm going to get 1 minus 2, which is negative 1. If I take the square root of 4 minus 2, I'm going to get 2 minus 2, which is 0. So let's go ahead and graph these ordered pairs. I have when x is 0, y is negative 2. I have when x is 1, y is negative 1. And I have when x is 4, y is 0. Okay, so let's go ahead and graph this. So before, when I had the function, let's graph it in blue, square root of x, my graph looked like this. Now that I have switched it to square root of x minus 2, you can see it changed my y value, y equals f of x, by negative 2. It shifted everything down 2. Oh, I graphed this wrong. It's when x is 1, 2, 3, 4, y is 0. There we go. Okay. My domain is all possible x values. My x values go from when x is 0 to positive infinity. My range, because it was shifted down to, my range starts at when y is negative 2 and goes to positive infinity. So this was an example of what happens when I have the square root of x minus a constant. Let's take a look at what would happen if this minus 2 or another constant was under our radical. So I want to take f of x equals the square root of x plus 2. And I need to determine what our domain and our range is. So the first thing I need to do is pick some values of x by setting my radicand equal to perfect squares. So I'm going to take x plus 2 equals 0, because that's a perfect square. X plus 2 equals 1, because that's a perfect square. And x plus 2 equals 4, because that's a perfect square. I'm going to solve each of these for x, so I would get x equals negative 2, x equals negative 1, because 1 minus 2 is negative 1, and x equals 2. So let's go ahead and plug those values. I have x is negative 2, negative 1, and 2. Now the reason I did this is so we get really nice y values, right? We want to get perfect square roots under that radical so we have really good y values, and makes it a lot easier for us to graph. Because not every number is a perfect square, so not every number has a square root. Let's go ahead and plug these in. If I take the square root of negative 2 plus 2, that gives me the square root of 0, which is 0. If I take the square root of negative 1 plus 2, that gives me the square root of 1, which is 1. And if I get the square root of 2 plus 2, that gives me the square root of 4, which is 2. So let's go ahead and plot these. I have when x is negative 2, y is 0. I have when x is negative 1, y is 1. And I have when x is 2, y is 2. So let's take a look at our previous graph. Y equals the square root of x. Okay. I did it again. There we go. These 3 points right here, right? So it looks like this graph, when we were adding 2 under the radicand, actually shifted it negative 2 to the left. That's something for us to keep in mind. My new domain is when x goes from negative 2 to infinity. And my range goes from when y is 0 all the way to infinity. All right, let's take a look at another example. So we added 2 and it shifted to the left. Now we're going to subtract 2 and see what happens. So first thing I need to do is choose my x values by setting my radicand equal to perfect squares. So I have x minus 2 equals 0, x minus 2 equals 1, and x minus 2 equals 4. And I did this because 0, 1, and 4 are perfect squares. This would give me x is 2, x equals 3, and x equals 6. Now I need to solve for y. The square root of 2 minus 2 is 0. The square root of 3 minus 2 is the square root of 1, which is 1. The square root of 6 minus 2 is the square root of 4, which is 2. So let's go ahead and graph these points. I have when x is 2, y is 0. When x is 3, y is 1. When x is 6, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, when x is 6, y is 2. Now it looks like my graph was shifted to the right because I was subtracting 2. My domain goes from when x is 2 to infinity. My range goes from when y is 0 all the way to infinity. Okay, so keep in mind how our graphs are shifting depending upon how they look. This is going to be really important in Chapter 8. So now let's put it all together where I have something under my radical and a constant on the outside. So again, I set up my radicand equal to perfect squares. Now that's just the x minus 3 part. So I have x minus 3 equals 0, x minus 3 equals 1, and x minus 3 equals 4. I add 3 to both sides, I get x equals 3. I add 3 to both sides, I get x equals 4. And I add 3 to both sides, I get x equals 7. I'm going to go ahead and solve these. If I take the square root of 3 minus 3 plus 2, that's the square root of 0 plus 2, so 2. If I take the square root of 4 minus 3 plus 2, that gives me the square root of 1 plus 2, which is 3. If I take the square root of 7 minus 3 plus 2, that gives me the square root of 4 plus 2, which is 2 plus 2, which is 4. Let's go ahead and plot these points. I have when x is 3, y is 2. I have when x is 4, y is 3. And I have when x is 7, over here, y is 4. Here's our radical. So as we can see, my x was shifted 3 to the right, and my y was shifted up 2. It moved where our graph starts. My new domain is when x is 3 all the way to infinity, and my new range is when y is 2 all the way to infinity. Last but not least, let's take a cube root. The only thing different about these is I would recommend finding at least 5 values, okay? And you have to set your radical equal to perfect cubes. The first perfect cubes are 0, 1, and 8. Also, -1 and -8. Okay? So here I have the cube root of x plus 8. So I need to set 8 equal to x plus 3 equal to these 5 values right here, okay, in order to solve. So I'm going to take x plus 3 equals -8, x plus 3 equals -1, x plus 3 equals 0, x plus 3 equals 1, and x plus 8 equals, x plus 3 equals 8. And I solve these. I subtract 3 from both sides. I get x equals -11, x equals -4, x equals -3, x equals -2, and x equals +5. All right. If I plug in -11, I get the square root of -11 plus 3. The cube root of -11 plus 3. That leaves me with the cube root of -8, which is -2. If I take the cube root of -4 plus 3, that leaves me with the cube root of -1, which is -1. If I take the cube root of -3 plus 3, that leaves me with the cube root of 0, which is 0. If I take the cube root of -2 plus 3, that leaves me with the cube root of 1, which is 1. And if I take the cube root of 5 plus 3, that's the cube root of 8, which is 2. So we're going to go ahead and plot these 4 points as they can fit on our graph. So I have when x is -4, y is -1. I have when x is -3, y is 0. I have when x is -2, y is 1. And I have when x is 5, 1, 2, 3, 4, 5. Y is 2. Okay? And the graph of cube roots always kind of looks like, the hieroglyph Egyptian arms. Okay? So our graph is going to look like this. Our domain goes from negative infinity to positive infinity. And our range also goes from negative infinity to positive infinity. So when working with cube roots, the most important thing is to set your values equal, under your radicand, equal to perfect cubes. And here are the first few perfect cubes.